Alright guys, welcome on back. This time we're going to cover how to simplify negative radicals, okay? So this all goes in hand with complex numbers, imaginary numbers, that lowercase I. So let's go ahead and start off with our simple chart. And I'm not going to be proving, I'm not going to be proving anything here, so I'm not going to write the proofs for y I squared. I guess I should skip a line. I squared. No, that fits. So I squared is negative 1. I cubed is the negative square root of negative 1, and then I to the fourth is 1. Okay, so this is our basic table, and we're just going to repeat these four values over and over. Again, I'm not going to go over the proofs. Your job here, if you're watching this video, is just to understand that these are my values that I'm going to memorize, and they are going to cycle. So I to the fifth here would be the same as this, square root of negative 1. I to the sixth would be the same as this, is negative 1, I to the 7th, the same as that, I to the 8th, same as that, etc. And you're going to keep cycling over and over and over the same values, okay? We're just going to talk about how to do the different kinds of problems that you're going to come across. This isn't going to be all inclusive, but it will, for our purposes, cover everything that we need to. Alright, so let's begin with just negative radicals really simply. And I think I will break this lesson up into several videos, so they're all going to be pretty short. That way, for those of you that are only struggling with one part, you'll just have to watch that one video, so it'll be a lot easier. Alright, so let's start with negative radicals. First off, the square root of, let's say, 25. Alright, really pretty. It's a perfect square, works out really nicely, and you know that the square root of 25 is the same as the square root of 5 times 5, because 5 times 5 is 25, right? Remember, your goal is just to find a pair of numbers that are the same. In this case, we have our 5 and our 5, so we get to pull one of those out. The square root of 25 is 5. Don't let this confuse you. A lot of you guys already have it memorized that the square root of 25 is 5 times 5. Alright, and then you know that the square root of 25 is 5. All good? So the idea is nothing new. Square root of 25 is 5. Just in case this is strange to you, square root of 16 is, and then you guys can take a second to think about it, 4. Square root of 9 is 3, etc., etc. A lot of you guys already know this. Again, square roots of perfect squares are really, really simple. It gets a little bit harder when we have non-perfect squares. But let's go ahead and introduce the negative radical part. So I'm going to use these same three values as my example. Alright, but now instead, let me go ahead and do this in a different color. The square root of negative 25, or the square root of negative 16, the square root of negative 9. Alright, you already know the values here. Alright, square root of 25 is 5, square root of 16 is 4, square root of 9 is 3. All you're going to do is you're going to pull out this negative here. Okay, so if we go ahead and pull out the negative, what happens is that you end up with the square root of a positive 25, and what times 25 is the square root of, I'm sorry, what times 25 would make it a negative? So you know that 25 times negative 1 equals negative 25. So it's essentially the same as this. The square root of positive 25 and the square root of negative 1. If you multiply negative 1 times 25, you will get negative 25. So this is the same thing. Okay? Here's the thing. Up here we already defined it. I is equal to that square root of negative 1. So you know that this one, the square root of negative 1, that's the same as saying I. I'm going to actually write that in brown right below it. So this is actually the same as saying times I. Okay? Square root of 25. Now, again, what is the square root of 25? You guys told me earlier the square root of 25 is just 5. So this is equal to 5 times this number down here, I. Your final answer is just 5I. Okay? I went through the process of explaining what exactly you're doing, but let's say that threw you off. Okay, this is a part of the video for you. If this didn't make sense, this threw you off a little bit, just understanding why I separated it all out. If that was confusing, this is easier. Okay, this doesn't explain anything. It doesn't mean you understand anything, but it does mean you can handle the problem. Alright, basically every time you see a negative sign, pull out I. Alright, so step one is to just pull out that I. Pull it out. Step one. And then change it to a positive number underneath. Step 2, go ahead and take your square root. What is the square root of 16? It's just going to be 4, which you already know. It's a regular 16. And then just tack on your I. So if you're taking the square root of a negative number, it works the same thing. Pretend it's not even negative, because all you're doing is pulling out I and get your answer. Square root of 16 is 4, and then because it's a negative 16, just put in that I. Okay? For this one, you guys should be able to do it yourself. Go ahead and pause the video here if you'd like, and give it a try. I'm going to go ahead and write the answer in just about a second. Okay? So over here, we're going to go ahead and skip the process of doing anything fancy, and the square root of 9 is 3, but I know it's a negative 9, so I'm just going to tack on that I. Alright? Any questions at all about that, go ahead and send them over to me in an email. Okay? But that's all that you do with these negative radicals. Now, for those of you that are lost on how to simplify non-perfect squares, okay, so we're going to deal with less pretty numbers. I'm going to go ahead and put this all on screen. And go ahead and pause here if you need to copy this. I'm going to go ahead and move on to the next page. All right, so let's talk about simplifying non-perfect squares. Let's just pick some numbers, like the square root of 220. All right, square root of 220. Now this one is not a perfect square. Um, a negative 220. This one's not a perfect square, so we can't do exactly what we did earlier. It's going to be a longer process. All right, to get an exact answer, what we'll have to do is go ahead and pull out your I. Remember, every negative square root, pull out I first. That's step 1 of 1, and then change this to positive. Now it's a positive 220. From here on, it's a little bit more familiar, but what you have to do is you have to break down this into whatever number it can factor out into. So you're looking for two numbers that multiply into 220. These could be any numbers. So you could just start with like 2 and 110, 22 times 10, 4 times, what is that, 54? Yeah, 4 times 54. Like, you can use any factors you want. I'm going to use, we're going to do it the long way. So we're going to do 2 times 110. Now, certain factors work out a lot prettier for you if you can figure out a perfect square that goes into this number. That's great. But what I'll tell you this is, if you're watching this video, you're likely struggling with this topic. So go ahead and just start with the smallest number that you can think of. Typically a 2, a 3, maybe a 7, but none of my examples will ever have nasty numbers like a 7 as your lowest prime root. You should probably be able to use 2 and 3 for most of them. Alright, so if we're using like 2 and 3 for the majority of my problems, I'm going to go ahead and break it down, and I'm going to break it down into all of its prime numbers. Remember, a prime number is just one number that cannot be broken down into anything but one in itself. If you don't remember what a prime number is, go ahead and look up a video on that. I don't think I'll be recording a video for this anytime soon, unless it proves to be a real problem. So I'm just going to keep breaking it down into really small numbers. So 2 and 110, 2 and, 55. And then from here, I can't break it down into 2 times anything anymore, but I know 55 is 5 times 11. Alright. And 11 doesn't break down into anything, it's just 11 and 1. 5 doesn't break down into anything, it's just 1 and 5. So I can't go any further than this. So we're going to go ahead and stop here for breaking it down. And now I have all these prime numbers at the end of my branches. Sorry, I was covering up that 11. But all these are prime numbers that are at the ends of my branches. And you're only dealing with the numbers at the ends of each of these branches. So 110, we already broke down. 55, we already broke down. We're only dealing with, and I'll highlight them in green here, the numbers at the ends of our branches. Okay? Just those. And what you're looking for, remember in a square root problem, oh, I have that backwards. There's a little invisible 2 there. I went ahead and wrote it in, but we never write that in math. Sometimes that's a cubed root, so you would see a 3, a 4th root, a 20th root, a 100th root, something like that. But there's going to be some number there. What that number indicates is how many of the same number you have to find. In this case, we just have to find groups of 2, or groups of pairs. So here's a pair. Here's a 2, here's a 2. They're a pair, right? There are 2 of them, therefore there are a pair. It's like a pair of shoes. And for every pair, you get to bring out one of that number. So we had a pair of 2s, we get to pull out 1, 2. And it's just going to go on the left of your radical here. And remember, we had that I earlier on, so I'm going to go ahead and rewrite that I. And after you've dealt with all of your pairs, if we had multiple pairs here, we'd pull out more. But we only have one pair, so we only pulled out the one number. And you're just going to rewrite your square root and throw whatever you didn't pair up back underneath. I didn't pair up the 5. There are no other 5s to pair it up. I didn't pull it out, so it has to go back under. Okay? This 11, I don't have any more 11s out here, so it has to go back under. Alright, so these things that I didn't pair up, they just move back underneath the radical. Alright? Next thing we have to do to simplify is we're just going to multiply right across. 2 times I gives you 2I. Don't make it complex. Times the square root of 5 times 11 is 55. And this would be the end of your problem. Okay? That's all that is. That's how to break down a negative square root. All you have to do is factor out and find your pairs. Okay? Theoretically, let's say there was another 5. So we would pair up both the 5s, and we'd have to... Actually, let me go ahead and give you a problem that would have something like that. So let me get multiple pairs. I think, let's see. I think 300 would do. So let me go ahead and break down 300 for you. Let me do this in a different color. Let's do this in purple. Alright. So we'll go ahead and do the negative square root. The square root of negative 300. Again, your first step is no different. That has not changed. You're just going to pull out that I so that the rest of your problem becomes a positive square root. Speaking of which, I didn't really mention this, but if you typed in the square root of negative 300 in your calculator, it would give you an error. This is why we came up with the imaginary number. This is why it exists. Alright, this is kind of its whole purpose. Now let's go ahead and break down 300. And you can pick anything. Again, I'm going to pick the really long way to do this just because I can. 3 times 100. And then, I don't know, 2 times 50. 2 times 25. And 5 times 5. Alright, again, up. What I broke it down into was the very, very long way. Shorter ways mean that you just see values that are the square root. I'll show you a second way to do this problem in 1 second, the way that I would normally do this on my own. Alright, so since we've broken it all down, let's go ahead and find all of our pairs. I'll go ahead and mark our pairs again. So I'll mark our branches in green. Remember, we went all the way from this top part all the way down. So these are all of our roots, and they're all prime numbers. Now we just have to find our pairs. I'll use, I don't know, purple, I guess, again. We have a pair of 2's. Excellent. So just like last time, we have a pair of 2's. But now this time we also have a pair of 5's. So I told you, for every time you have a pair, you get to pull one of that number out. So we get to pull 1, 2 out. Alright, so 2. And then we have to pull 1, 5 out. 5. Don't forget you had your I already that you pulled out at the very beginning. Now that we've done everything that we've paired up, we're going to put our square root sign back and put whatever is left over back underneath the radicals. So we paired up the 5's, they're gone. We paired up the 2's, they're gone. All that's left is this 3 up here. So I'm going to put that 3 back underneath this radical. You're almost done. The next step is just multiply. 2 times 5 is 10. Times I just gives you 10I. Then don't forget your square root. Bring it on down. Alright, bring it on down. And that would be your final answer here. Alright, so just to remind you guys, I'm going to go ahead and bring this up all on one page. And if you guys need to pause here, feel free. I'm also going to bring it up one more time in the end. Alright, so feel free to pause here. That is the work for that one. I'm going to show you how I would break down negative 300 on the next page. Alright, so let's go ahead and break down negative 300. I'll go ahead and do it in the same color. And you guys can compare the difference at the end of this video. Alright, so if I'm breaking down negative 300, immediately I know that the square root of 100 is 10, because that's 10 times 10. So I can actually do this really easily. Remember, you're always going to pull out this I, alright? And because I pull out this I, it's no longer a negative number. That looks like a star, but I really just meant to X out that negative sign. So it's a positive 300. Let's go ahead and break down positive 300. 3 times 100. And I told you guys earlier that I know the square root of 100. What is the square root of 100? It's 10. So I don't even have to bother going any further in the problem. I know that that breaks down into 10 and 10. There's my pair of numbers. Okay? And then you would pull out 110, don't forget your I, the square root of 3. This is the same problem as earlier, but it's a lot quicker because I noticed that there was a perfect square that I could break this down into. You could have also done 25, you could have also done... okay, that's actually all the ones that are pretty that work in here, but 125, both of those would have broken down quicker and would have saved you a step. But, you know, if you don't notice this, just break it down into the smaller numbers. It's not that big a deal. Okay, let me go ahead and compare the two for you. So there's that one, and then there is that one there. Alright, Same problem, same exact problem, and you'll notice that I broke this one down in 3 and 100. This one I also broke down in 3 and 100, but let's pretend I didn't notice that the 100 could be broken down, or I'm sorry, could be a perfect square, so I keep going. I keep going. 25 is another perfect square. I could have noticed here to break it down, but let's say I just kept going. It doesn't matter if you have to go all the way down. You'll end up with the same answer, 10i root 3, 10i root 3. Neither of these are wrong. They're both exactly the same. Okay? So I'm going to go ahead and get each page on screen for you guys to copy down, but that covers everything that you need to know for simplifying negative radicals. Alright, so there's page 1. Feel free to pause here. I'm going to go ahead and flip to page 2 now. Alright. And then there is page 2. And feel free to pause here, copy that down. And then there is page 3, which is really unnecessary. It's really me just showing you that you can do it a lot quicker. Again, if you're watching this video, likely you're struggling with it, start with the basics first, and then you'll get more comfortable and be able to do this later on. Alright guys, so good luck with simplifying negative radicals, and I will see you in the next video on complex numbers and conjugates.